Thank you, Deepthi ma'am. Thank you, Anita ma'am. Thank you, Ritesh. Thank you, Pramod sir. Thank you, Gopal Raju sir. Thank you, Venkatraman. Okay, so I'm just going to start. So in today's session, we are going to revise the linear algebra module of the session. Thank you so much, sir. Okay, so for the people who have recently joined, right? So the people who have recently joined, I'd request you to go through the actual lecture also. So I'm now going to point you in the direction of how to identify where we are in the revision hackathon. Okay, so but before that, let me go ahead and check if my audio is clear. If my audio is clear, type A in the chat box. Okay, great. Thank you so much. Thanks, Ritesh. Thanks, Deepthi ma'am. Thanks, everyone. So now, basically, if at all you log into your course, people in all the courses like bronze, silver, and gold, you'll be able to see that this is how your flow of the lecture would be, and in that we have covered each of these modules by revision. Right, so the format of the revision hackathon will be in this way. First, there'll be the revision, the actual lecture done by either Professor Rajiv or Jain sir himself, and we are going to revise those concepts within the revision hackathons, right? So you may choose to directly go through the whole flow of the actual lectures. You can actually go through that lectures and join the revision hackathons, or you can, if at the point of recording or the time of session, if you're not able to attend, you can go through the actual lecture and the recording of the revision hackathon. This will be available in your inner circle, right? Okay, so now we have completed a few modules, and now we are in the linear algebra module. Comparatively, it is a very smaller module. I'm just going to share my screen here. Okay, it's 3.4. I think it's already shared. Okay. Here we are. Okay, so for the people who have recently joined, I'm you can start from the beginning, or you can even be part of this session and also understand what is happening here, understand briefly what is happening here, and also go through the actual course flow. Okay, so I'm going to share this Collab file, the exercise file. So the people who are new to Collab, do not worry. I'm just going to give you a simple instruction of how to do that. So I'm going to click on. I'm just sharing this particular Collab file with everyone, right? So if at all, if at all you are for the first time opening Collab, so you have to go open the link that I've shared on chat, click on file and say save a copy in Drive, right? So it will open in new tab and you can work from there. Okay, so that is about the initial setup. And if at all you are not able to find this Collab file, the way to find it out is you can always go into the lecture, and just below the lecture, you'll be able to see that there'll be a link. When you click on this, it will open up the Collab file. You don't have to actually wait to join a Zoom session or get the Zoom link. Okay, great. So now let's go ahead, and I'm just going to start. Okay, so in today's session, what I'm going to do is first, let me go ahead and clear all outputs. This particular session will be a smaller session when compared to our previous sessions. In this session, the thing is, it is more a numerical or assessment more than analysis. Okay, so people who have joined us on YouTube, I request you to mute. Right, so yeah, thank you so much. So this will be lesser of data science, only this particular module, because we are going to revise the basic concepts of linear algebra and matrix multiplication, the concepts you might have seen long back, right? So we're going to revise them to understand the prominence of that in machine learning and in our model building. And as we proceed forward in our upcoming sessions, this knowledge would be helpful, right? So this is like a bridge between both of the modules, right? It's like a bridge module. Okay, so let me go ahead and set the objectives. So if you've gone through the actual Jane sir's session also, you would have understood the whole flow of it. Even Jay sir says you do not have to actually heavily focus on the the NumPy logics because of this module, because these are not data science related. These are more of Python or NumPy related. Okay, so do not try to dwell deeper and try to confuse yourself. We're going to keep it simple. Right. So to go by objectives, first we are going to define the vector and calculate the vector length and dot product. Right. So if the terms seem familiar, we're just going to understand them as well. Right. So we'll also are going to define a matrix, do matrix dot multiplication, transpose, inverse. Then also understand what is something called cosine similarity, right? Which will also do a small exercise to understand how such small functions are useful in the actual real-time applications, right? So we'll use linear algebra to solve for linear regression coefficients, right? So when we said simple linear regression, in that how this linear algebra played a role, right? So we also need to understand, right? So it's not that we only understand the OLS formula and understand everything, right? So we are going to understand the a little background about it. Okay, so let's go by first defining a vector and calculate a vector length and product, right? So for that, what I'm going to do is I'm just going to open our multiple regression, or let's say simple simple linear regression assessment also here, right? Okay, so now we have seen in our previous sessions how to calculate the slope and intercept from our data, right? So the equation, now if you see here, we got this intercept and slope in various cases when there were three dependents, like y was dependent on three variables, like y equal to this kind of an equation, or we had two such variables in our previous session. Like if you see in our 3.2, we had the intercept and the slope, right? So let me go ahead and just bring it up. Yeah, so we had this. Okay, so we'll see how we were able to achieve this coefficients and this nitro. Okay, the background, the behind the scenes of it, because the linear regression used a little of linear algebra here. We'll try to understand that. Right. So just before getting into the depth of it, we'll try to understand, like reintroduce our concepts for vectors. So if you remember vectors and matrix multiplication, right? So whenever you have a vector has its magnitude, which is nothing but the value, right? So we are also going to understand more of it. For example, if there was a vector, let's say A is the vector name and the values in that are 3, 4, right? So what this would signify is a two-dimensional vector, which is easy to plot. So I'm just going to go ahead and plot this. So people who are just getting the understanding of Collab File, just go ahead and click on the run function here. So what this will do is run all the lines of Python code here, right? So in our previous sessions, we have explained this in a deeper fashion. So here you can just go ahead and do that. So now you can see that first we are importing the matplotlib here, which will help us see things visually, and then we are defining a variable called vector and giving it 3, 4 as the array or the list, right? So what is happening here? Then we are going to plot an arrow starting from 0 with so and so magnitude and width, right? So now if you see here, when we said 3, 4, 3 and 4, 3, 4, starting from 0, 0, that particular vector got plotted here, right? So this is what happened here. I think this particular diagram was straightforward. You understood what happened here, how we were able to plot the arrow, we use the plot dot arrow. We have defined what should be the width of that particular arrow and everything, and then we plotted that particular arrow starting from 0 till 3,4. If this was clear, type C in the chat box. Great, thanks, Ritesh. Thanks, Anita. Okay, so now 0, 0 is nothing but the origin, right? So it is starting from, like fx comma y. Thanks, Ravinder sir. Thanks, Deepti ma'am. Right, so 0, 0 here is the origin, right? So all the vectors that we are talking right now, for simplicity, all of them will be starting from the origin. So 0, 0 is that. Okay, and now if it was a simple vector, this is how it will go. But if it's like a complex vector, like now if we have to have a vector with multiple magnitudes or multiple dimensions, right? So then how do we do that? We can even try to plot them, but that is not related to our scope currently, right? Now there were a few formulas, if you remember, vector multiplication and all. So first, what I'm going to do is every vector has its magnitude, which is also known as the length or norm, right? So we are introducing the term norm, which is, you might have heard, like vector has a direction and a magnitude, right? So even in physics also it comes, in maths also it comes. Direction related things more in physics, but magnitude related things more in the maths, right? So now the length also is known as the norm of a vector, right? So now the magnitude formula was always this, right? So for example, there is the beginning point and the ending point, like a1 comma a2. If the vector has a1 comma a2 as its internal elements, then the magnitude is going to be square root of a1 square plus a2 square, right? So the magnitude of that particular vector here would become under root of a1 square plus a2 square, which becomes 4 square plus 3 square, nothing but 5, right? So it's good to remember the formula also, but as we all know, Python has got formula for each of it. This is the mathematical formula that if you want to remember, you can remember. But there's a formula that we'll explore, which will directly give us that particular value, right? And what was the dot product? Like if you remember two matrices, like if there's a matrix, which is, one row, one row and 3 columns. And here also is 1 row and 3 columns. So whenever you're doing a multiplication of matrices, so which is B dot C is going to be B1 C1, B2 C2, and B3 C3. And that is how you're going to get your value, right? So the matrix multiplication of the vector B and C is going to be 65, right? So this is how you do the matrix multiplication. We'll also see 2 by 2, 2 by 3 kind of a matrices also, right? So I hope this brings back a little of understanding of your matrices and vectors from, previously. Even if you don't remember, recollect, not worry. Right. So now these were single row vectors. Now there are multi-row, multi-column vectors also. Like for example, if A is like a 3 by 3 matrix and B is a 2 row, 3 column matrix. Now, what are we going to do here? We are going to use a little of linear algebra to generate simple outputs here, right? So we got the matrix and the number of rows and columns that a matrix has, it's called as its dimension, which is something that we all know, right? We do in arrays or NumPy, the shape is nothing but the dimension that comes, right? So when listing the dimension of a matrix, we always list rows first and then columns. These are like simple things, 2 rows, 3 columns, 2 by 3. Now, using linear algebra to model the relationship of long bone nitrogen composition to intermittent time, which was nothing but our previous exercise. We were trying to do our linear algebra modeling here in our previous example. So what we are going to do here is, in linear regression, the formula that relates every value of x to its value of y is something like this, right? So if you remember, y equal to mx plus c kind of an equation only. And here the EI is the residual for the ith individual. You can kind of ignore it. So for our case, it is not specific, but you have seen the equation of R lines in our previous sessions also, right? So we had equations of similar format as well, right? So more or less the same thing. Now, what are we going to do? We're going to just bring in the same data set that we used in long bones and try to see how we have got the same thing. So this is the familiar long bones data set. Now, if at all we have to do the linear model for regression, so we are going to do the same way, right? So what was the equation? Y equal to mx plus c, that kind of an equation. Now, y, if you remember, was time. If you remember, we have plotted the graph also somewhere. Okay, so I have to run them. I'm just going to run them for while it runs. You remember there was a scatter plot on y and x, right? So now y here for this first element was 71.8, which was time, equal to b0 plus b1 of x1. Here we are only talking about the relation between time and nitro, right? So if you go by time and nitro, let me see. Yeah, we're going to just see time and nitro. When we just see the relation between time and nitro, the equation would be 1x1, 1y1, right? So this is how it is going to be, right? So for example, if you want to do the for second individual, y would be 70.6 and x would be 3.53, right? So this is how we get equation of each of the individual record or observation. Now, what behind the scenes, when we are doing the linear regression model is happening is the whole of the data set is being taken into matrices, right? So y here was taken, whole of this time column was taken here. Yeah, so basically these are constants here, Vinitha ma'am. So we are not kind of more dwelling onto those values. It could be like now, yeah. Here B, no, we have not specified anywhere B being biased. Now, if you remember in our multiple regression, what we have said is now Y1 is also dependent on multiple things, not just one nitro, right? Just to signify that it's also relevant, it's also related on other pieces. We are just writing those things, writing the values of it, right? So bias, whenever we are doing more of models, Ritesh, we are going to bring bias more into picture, but here they are going to be something which is not known here for us, right? I hope that is clear. Yeah, so we are going to discuss more of bias while we are doing models. So as you remember, this particular linear algebra, we are only trying to stick to the NumPy portions of it. As you see, we go forward, it becomes more and more clear, right? So you're not going to confuse all the other elements thinking of forward. Just because we have the knowledge of other modules, we kind of tend to confuse. But I'm just going to tell you more, we are concerned here on the rows of y and x, right? So as we proceed forward, we're going to also see biases and all the constants as well. Cool. Okay. Now, so what is happening here behind the scenes is y as a column has been taken as a matrix here, and x as a column has been taken as a collection. Yeah, so that is the confusion, Ritesh. We're not considering. So if you go by Sir's module also, this is how the equation of the regression model equation is happening. Now, if you remember in our first concept, when we are doing the simple regression, okay, so let me just put this below. Now, if you see y equal to mx plus c, when we are doing simple regression, simple linear regression, we thought like y is just related on to x, right? So the intercept here was 316.8, right? Now, y was related to x and the intercept was so and so, and the slope was so and so. So this is what we have gotten here when we are making an equation in this particular way. But when we went on to multiple regression, we also knew that y is not solely dependent on x. There are other factors also, right? So currently we are not kind of getting onto the assessment of what other factors or other constants or the elements are, right? So we're kind of only concerned with how the matrix multiplication is happening here, right? So our constant is our concern is more of x, the values of x here, so the xi. Okay, great. Okay, so see, it's always because we are curious by nature, we would also want to understand what other elements is. But then like Chaser says, whenever we have to approximate to get to one end, right? So we'll not be able to progress while we stick to one topic while we dwell into other topics. So as we proceed forward, we are going to, when we do models, then biases and everything comes into picture, right? So the other elements could be the intercepts, if you're talking mathematically, but if you're talking more into model based, it could be bias or the other things, right? We're not concerned with that, right? So now we're more concerned with the matrix multiplication that is happening behind the scenes, right? So you already know the result of how the OLS model summary is coming. We are just kind of taking a back step and trying to understand behind the scenes how the matrix multiplication is happening, right? So now here, if you see, if at all you are looking at the names of these things, you can see that here the residual, it's also mentioned that EI is the residual for the ith individual, and we're not kind of getting into that currently, right? So now, if we go forward, the regression coefficient, which was our slope, which was the slope connected to x, right? So y equal to mx, this becomes our m, and that is where we get our regression coefficient, which is minus 69 in our the whole equation. And in this particular example here, the slope still will be regression coefficient, right? So we are not trying to name these elements in a generic sense. We are trying to name these elements in our long bone exam, right? So do not consider B0 will not be always regression coefficient, or E1 or E2 will not always be the residuals. Okay. So now these are the matrices that behind the scenes the model is making. Y is the column of time and X is the column of ones and all the nitros, right? So we have got all of these. So it will make a long list of this. Now, if you remember, what is the regression model? Y equal to mx plus c, right? So now what we're going to do here is do something similar. The matrix multiplication is also going to happen in the same way. So we are going to substitute the same values, but with matrices. So the Y matrix here was the whole matrix, right? So here we were taking individual why there are ones. So we'll also understand more about the matrix multiplication. So now how matrix multiplication happens is Y equal to, so now when you multiply this by X, right? So as we proceed forward, you'll understand here. Now Y equal to mx, like B0. So let me just go ahead and show you the matrix multiplication. So now how matrix multiplication happens is, first you multiply a row with a column. So 1 into 7 plus 2 into 9 plus 3 into 11, right? So then the value comes. So when we are taking it in this particular fashion, now the equation is going to be like this. So 1 into B0 and 3.88 into B1. So 71.8 equal to B0 plus 3.88 B1 plus E1. So that is the reason we the ones come into picture, right? So the matrix multiplication happens in that particular way, right? So I hope Ritesh, now it is clear why we have ones in the X matrix. Cool. Right. So now we have, if at all we had only the single equation, y was a single value, but because we have to get the coefficient of the whole of the set, whole of the column, we are going to use the matrix here, right? So in wherever the equation y equal to mx plus c kind of an equation, x will be the x matrix, y will be the y matrix, b will be our regression coefficients plus the constants E1 to E5 or the residuals, right? So now this is our equation. So how many of you are clear only on the matrix multiplication addition here, right? So y equal to mx plus c, instead of just putting 71 and these values, we have substituted the whole of the matrices. If you're clear with the substitution of matrices in the equation, type C in the chat box. Thanks, Ritesh. Okay, so thank you, Deepthi. So for people who have not understood, okay, most of you got it. So the matrix multiplication happens in this fashion. You multiply the row by column and add them, right? So for example, if this particular matrix, this 2 by 3 matrix and this 3 by 2 matrix, if you're trying to multiply, the result is going to be like this: 1 into 7 plus 2 into 9 plus 3 into 11, which is 58, comes here. Similarly, first row, second column, second row, first column, second row, second column. So you get all the values and add them up here. So similarly, substitution of matrix also is happened here because we want a total value. We are not just doing individual substitution, we are doing the whole matrix substitution, right? So now that is clear. Now this is the explanation of that. Now coming to our long bones example. Now what is happening here is this will become our B0 plus basically mx plus c, right? So this has been expanded here. We've already understood it. This xb is nothing but x into b, and that has been done here, expanded. And E is nothing but the constant. So all of that is going to be y equal to B0. So 71.8 equal to 3.88 B1 plus B0 plus E1. So this is what is going to happen. So now we have understood the matrix substitution in all of the equation. No, okay. So basically, now when we, I think I understood your question, Venkatrao sir. So basically, why we have taken only 2 coefficients here, right? So that is that the question? Yeah. So now that is simple. Now, if you see our simple regression example, now what we are doing, we are comparing y with nitro, right? So the time with nitro, which is going to have mx plus c. So it is going to have 2 coefficients, right? So now if you see, one regression coefficient we already have and one intercept, we're also going to have it here, right? So now for whenever you do the sum of it to get an equation such as this, right? So y equal to mx plus c kind of an equation, you're going to substitute the same number of coefficients, right? So because the multiplication happens this, for example, if there were more values, you would have had more coefficients in that. Like for example, if we are doing the comparison between like we did area, right? So we had we had also C line, nitro and intercept. So in that case, you would have 3 coefficients, and that for that, then you'll have B0, B1 and B2. Yeah. So I hope now it is clear, Venkatraman. Okay. Thank you so much. Now we had these two questions. Basically, you do not confuse. Basically, you want to substitute, right? So basically, you are not substituting. This is happening in the behind the scenes. You will never have to actually do matrix multiplication by yourself, right? Because you have the whole model with you. But what you are doing here is trying to get the equation in matrices. So for you to get an equation such as this, you would have to substitute B0 and B1 only in the coefficients. For to have a bigger equation, you would require B0, B1, B2. We're not going to name any of these elements here, so that will cause more confusion, because now if you've already seen what is a residual, what is coefficient, regression coefficients, we are just going behind the scenes to understand everything. More we are concerned with the slope or the x value and the y value, right? Yeah, so maybe I understand where you're coming from is vector being having the weights and the lengths and all. So we're not getting there. Okay, so now we've understood how we have formed the equation. Now because if x into b equal to xb, how would we only get b, right? So if you want to do the equation of that, so y from the equation y equal to xb, so how do we get only b? Because what do we require here? We want what the model requires here. It wants to come up with the coefficients of the whole data set, right? So for that, the equation comes handy here, right? Now all of this also has been explained by Jain sir also. We'll try to understand each of this. So whenever you see a matrix with this, it is going to be the transpose. It is also referred to as a matrix to the power t. And whenever you see -1 over that, it's going to be invert, right? So we are also going to see that. Don't have to remember all of that. Now, if you see this equation, right? So now y, okay, so let me just try to put this on a Excel sheet. Now the equation is b is equal to x inverse, so x transpose into x minus, okay, so I think the equation did not copy properly. I'm just going to simplify it here. B equal to x transpose into multiplied by x and inverse of it, right? And which is nothing but the reverse of that, and then multiplied by x inverse again and to y, right? So this is the equation for us to get the coefficients. Now this is something you might want to remember if you want. Whenever you're trying to get the coefficients of the equation, it is going to be of format y equal to x transpose into x to inverse into x transpose of y. If at all you were doing simple mathematical operation, the b would be y by x, right? So you would be just doing y by x. But now when you're doing a matrix multiplication, you are getting the b by this particular equation, right? So this is also something you would just want to understand. This is what is happening behind the scenes to calculate the coefficients, right? So basically, whenever you want to calculate the B0 and B1, you're going to send this x this way and bring b's together, right? So in the equation, in this particular equation. So that is happening here, but in matrix format, not in a regular algebra format, right? So the transpose is something very easy. Like if at all you have a matrix here, 4x4 matrix. Now you see A, B, C, D, that becomes, the transpose of it, right? So I'm just going to explain it here. So for example, 1, 2, 3, 4. If this is going to be the equation. Now, when you copy this, you can see that in Excel also you have this paste special, and you can see transpose. So what happens is when you transpose, 2 comes here, 3 goes this way, and you'll have the transpose of that particular thing, right? Similarly, here also, whenever you transpose any set, any rows by columns, it's going to be converting rows into columns and columns into rows. That is transpose. And inverse is going to be an equation, right? If you remember, like A inverse equal to 1 by AD minus BC into the matrix, D minus B minus C minus A, right? So this is an equation, if you're familiar, if you recollect. So how many of you recollect, reading or learning about A inverse? Yes, thank you so much, Shankar. Thank you. I also, Ritesh remembered it, but hated it. Yeah, so it was such a thing. Now what happens is matrix multiplication, whenever you're doing the A transpose and A inverse, now Ritesh, you can be happy because you don't actually have to do all of this. Thank you, Vinita. Yeah, so we all, are relating with each other. We never liked it. Yeah, libraries do it all for us. Thank God for computers. Thank you, Ritesh. So basically what we are going to do is we are just going to do the same thing by using formula, where whenever we want a transpose, we do dot transpose. Whenever we want to do a multiplication, do mat multiplication. Whenever we want to do inverse, we do linear algebra dot inverse, right? So this is the libraries that we are going to use, right? So now to achieve the same B coefficient, first thing is there are these libraries and functions which have made our lives already easier, but then there was OLS which did all of this in the backend and just gave us 2 values, right? So it's super simplified, but we're just going to understand all of this. So what is happening here is this is the data set longbones.head, and now what we are going to do is first take into nitro the column nitro, and we are going to just do reshape. This is like a matrix thing. I'm just going to output that. Now, if at all you want to print nitro. Yeah, so sir, does gradient descent also perform matrix multiplication, or is it OLS? I'm more sure, even in the actual session, matrix multiplication is actually the core to many models, Ritesh, right? So even there were like complex algorithms even used in machine learning and all, which are being done matrix multiplication. But I'm not completely sure if gradient descent and the other things also use matrix multiplication. Maybe we have to search about it. Right. So maybe I want to take that and come back on that. Right. So now what is happening? We're going to take nitros and ones. So what is ones doing here is, if you remember, we had this all ones. Ritesh's question: why do we have ones all here? So we are going to take nitros in one column, ones in one column. That is what we are doing here. Now, what are we doing with ones is repeating once as many nitros, like how many ever elements are there in longbow. So 1 till 35, go ahead and have so many ones in this particular column, right? So now y is very easy. Y is going to be time, and x is going to be ones and nitro, right? So if at all you are going to print x now, so it's going to be ones and nitro, right? So you got them, and y is simple time, right? So I'm going to print y. So you'll have your time, right? So we got our arrays. Now we are going to do the transpose of x to substitute here, to substitute in to get b. We are going to do the transpose and save it in x underscore t. We are going to do multiplication of transpose with x, right? So we have to do transpose with x multiplication, and we are going to save it in transpose into matrix multiplication here, and then we are going to do the inverse of whole of it in by using the linear algebra dot inverse and this particular variable. So it's becoming the the equation and everything is simple, but the variables are names are complex. Can you repeat X? Okay. So now what we've understood is this is diagrammatic. Here, when we said y equal to mx plus c kind of an equation, y is time and x is ones and nitro. So this is diagrammatic. There's no there's no formula or anything done here, ma'am, right? But if we want to do that in columns, what we have done is we have taken all ones and all nitros and then made x out of it, right? Yeah, so thank you so much, Ritesh. So people who have also attended Rajesh's session or learned about gradient descent, Ritesh confirms now that gradient descent also uses matrix multiplication, which is behind the scenes. You don't have to do it yourself. Okay? So now coming back to Vinitha ma'am, now if you see, this is diagrammatic, and what we are doing here is trying to make that in a array format, right? In a data frame. So what we have done here is, first we have taken nitro. So I'm just going to go step by step. Okay, so I'm just going to print nitro here. Now you got all nitros in one column, right? So that is there. Now then what we have done, then we've got all ones, right? Because we need ones in our matrix. So we've got all ones. So I'm just going to print ones. So now you see there are how many ones, as many observations are then in long bones. So basically to match how many nitro columns are there, how many nitro rows are there, similar number of ones we need. So for that reason, we had made another data frame, called another variable where we have saved all ones, right? So now what is our X? Our X is nothing but ones and nitros. So what we have done our concatenate and added our ones and nitros as column by column, right? X is equal to 1 is column addition, and then we printed our X, right? So this is what we have done. Now we have got our array, right? So X will have this. To actually do the transpose and multiplication, we should have the array, right? Yeah, so the reshape is something that we are using here. I would want to, see if what happens if we remove them, because in the actual, yeah, so reshape is something that we are using for us to, get out of it. I'm not completely sure about reshape here, ma'am. So this is for us to get into the array format. I'm not completely sure, maybe we'll have to work with that. We'll have to understand more about it. Yeah, so even Jayan sir said this is the format for us to, create that particular array. Ritesh, any idea on what reshape is? Okay, let's go ahead and see then. Okay. In NumPy, -1 in reshape refers to unknown dimension that the reshape function calculates for you. It is like saying, I will leave this dimension for the reshape function to determine, right? A common use case is to flatten a nested array of an unknown number of elements to a 1D array, right? So basically, as much as I understand, yeah, thank you, Ritesh. So even because, Jason has left us with that particular formula, we are going by it, but as I understand it, more about it, it is converting the matrix into a format which could be flattened, meaning only values of that will be added into the nitro, right? So that is what I feel, but I would also be more curious on learning about it. So thank you so much, Vinitha ma'am. I'm not completely sure, like a few of those things, because the whole exercise of today's session is just going behind the scenes to understand. But I think reshape is something that will come handy in our upcoming sessions also. So I'll also go ahead and understand more about it. If you go ahead and understand more about it, please do share. Okay. So now Yeah, so Vinitha ma'am, goes to minute details. I think that's a very good thing. Okay, so now we've got our arrays, right? So now what is going to happen? We've got our X and Y. We are going to do transpose of each of these inverse and multiplication by using these functions, right? So now we've got all of these 4 variables, right? So we have our X inverse, X transpose into X and inverse of that. So we have all of them. So now we are going to do B, which is the matrix multiplication of X transpose multiplied by X and inverted with X transpose multiplied by Y, right? So then we are going to return B. Okay. So now when we do that, we are going to, right? So let me just go ahead and print B. Let's try to say B. Okay. So did we just go forward and did it? Okay, so I think because B was also calculated below, we got the equations from B. So did I not run this? Okay, let me go ahead and run this. Okay. We did take 2 of our variables, right? Yeah, so give me a second. Okay. Yeah, so now what has happened here is something that I'm also, just kind of going back. Here, are we just taking nitro, long bones, and all of this, right? We're going sequentially only. Yeah, I'm just going to run all of this again, just to be double sure of what outputs we are getting here. Okay, so the B array consists of the value. Okay, there was a function that was made. So let me just go ahead and find the function. Give me a second here. I'm just going to try the function get B. Okay, so because we have not understood, okay, this is the function that that was created. I'm just going to, this is the function definition. Okay, so I'm just, yeah, Y is always time. Yeah, thanks, Ritesh, for that. So now what we have created here is, here we have created a function which is going to calculate all these values and return B, right? So now when we are returning B, for example, whatever values of X and Y you're going to pass in here are going to be, give an output in this particular format, right? So here, what we are doing is, I'm not going to print B here because B already has some values which were calculated elsewhere. So now, after doing this particular definition, so how many of you are clear with the function definition till here? If you understood the function definition till here, which is nothing but calculation of B. So what mistake I did here is I directly went ahead and printed B without calling the function, right? So if you've understood till function definition here, so what we are trying to do here, we are trying to get B. If you understood till here, type C in the chat box. Okay, so it's very clear. Here, a function was made which takes 2 inputs, which is the X and Y, and internally it does transpose, inverse, multiplication and everything, and gives us B, right? So now what we are doing here is, we are going to create a new variable and calling the function get B, passing X and Y as our variables, right? So now when you are doing that, that is where you're getting your values, right? So now if you see a whole of this in your multiple regression models, all of your coefficients, right? So 180, 25 and minus 35 are here, right? So this is what is happened. And if at all, if you go ahead and do the same kind of OLS equation manually, you're going to get the same intercept and Y, the nitro, we get the same answers. I am just kind of taken aback because we are getting the values of the second equation. Right. So we are getting the values of this because I want to change the variable names from B to something else here. Okay. Having the same variable names is always a challenge. Right. So let me go ahead and say create B1. Okay. Let me see if this is going to work. And get B is the function that is coming, and the whole of the calculation is happening here. Okay. And I think we have to change the names X and X1, right? So I'm just going to return X and Y again. Okay, so we have X and Y here, and we are going to also, they should not change much. Okay, so see, the variables names was getting a little bit confusing. So what happened here is in our next exercise, we also named it B. And because when I ran all of it again, and when I'm trying to print B, you're actually getting the next values, right? So now what I've done here is I've just passed in the values of X and Y into this function. And within this, now you're able to see that the coefficients have been received, right? So B, what was B? Our B here was B0 and B1. And now we have received our B0 and B1 here, right? So if you see the same thing, the OLS equation does all of these steps and gives us the same B0 and B1, right? So if you're clear that what the OLS did in back B, if you have understood that, type C in the chat box. Yeah, okay. So Vinita ma'am, what we have done here is to do the transpose calculation of B, right? So to calculate B, a function was made. So basically, what was made here is a get B function. Okay, so I'm just going to leave it. So this is what we need to get. So there was the name of that function was named as get B. Okay. Sorry. So let me, sorry for the confusion. Let me go ahead and do it. So we are clear with the equation formation. We have understood everything till here. Now we have understood how we got X value, right? We have added ones and 3.88. Ritesh, thanks for clearing the reshape part of it, right? And Y is it an inbuilt function? No, it's not an inbuilt function, right? So now if everybody is clear how we got X and Y, if you're clear till there, type C in the chat box. Okay, X and Y are clear. Now, X and Y are clear. Now we have to get B. Now whole of the equation of the B is nothing but transpose of X, inverse of X, like inverse of X transpose and X transpose multiplied by Y, right? So all of these have to be calculated. Now what the function here, the get B function is doing is doing this within the function and just giving us B, right? So I'm just going to, now we have got X and Y. Now we have made a function. So definition is this get B is not an inbuilt function, right? So we have made a function which is going to be called get B. Like instead of get B, you can say, let's generate B. Okay, so you call it anything, right? So you are creating a function, you are defining the function, giving the semicolon. These are the parameters that you're going to pass. And these parameters are the variables or the arrays that you have created, right? So that is all done. So this is the function header. Right? And these are the steps within that function. This is the body of the function, right? So this is all, this is where the body of the function is starting. So it's a function that we have created for ourselves, right? So within that function, what is happening is X transpose is getting calculated in a variable, the inverse of X transpose into X is also getting calculated. So first it is being multiplied. So the matrix multiplication of X transpose and X is happening with the use of the function mat_mul, which is multiplication, matrix multiplication. Okay. And this is transpose of the matrix, right? Similarly, here what is happening? We are doing the inverse of whatever transpose we have got here, right? So whatever we have got here, the multiplication of X transpose into X, right? So how many of you are clear till this step of the definition? We are multiplying X transpose with X, right? So if you're clear till here, yeah, great. Now what we are doing inverse of it, right? So which is nothing but the function for the inverse of multiplication is linear algebra dot inverse. So now you've got the inverse also. So now you've got till here. Now we have to multiply it with X transpose again. So we are doing inverse of that again multiplied with Ry, right? So we are going to do here. So we have got it here. The inverse also is ready here. Now we are going to do X transpose Y, which is this. Here we are going to do X transpose Y, and that is also calculated here. Right? So now we have got all of the ingredients for us to get B or generate, right? So how many of you are clear? So we have just got our ingredients ready here for us to generate B. If everybody is clear till here, type CG. Okay, thanks everyone. Now what we have done here is I have just named that instead of B within the body, I have just named it as B1 because there are in the same collab file, there is another place where there is B. So I just named it B1, and this is going to return this particular value. So the whole multiplication done here is being returned, right? So now what we are doing, we are creating another variable here. I'm just going to call it, regression coefficients long bones. I'm just going to make it descriptive, right? So I'm just going to make a new variable, say regression coefficient of long bones, and calling our function. Let's say our function is generate B, right? So we're calling our function which we just now created. And what are we passing into it? We are passing the arrays that we have created, right? So we are passing the arrays. So how many of you understood till here? Type U in the chat box. Great. So now we have to see if our function is working. So I'm just going to run it and then print our variable, right? So I'm just going to run it. And okay, so let me just say generate underscore B. Are we just using it proper? Okay, so sorry, I have to run this first, right? So now I have defined the function, run the function. Now I'm going to run this here, right? So if you've understood what we have done, we have created a function. So this function is helpful in our next example also. That is why we have created a function, or else you have to do it every time for, like for example, there is another equation that you have to do. You have to do it every time. Now you just have to pass X and Y into it, and this function will do it, right? So now if you understood how we have got our B value, right? So now if you see all of this B, if we do all of this equation, we are going to get our B here, right? So what is our B? Our B is B0 and B1. So we have got our B0 and B1 here. Where is that? Yeah, B0 and B1 here, right? So now this is what we have done manually, right? So if you have understood what we have done right now, type U in the chat box. Okay, so you have already done it. Okay, thank you so much. Now this we have done manually. Transpose, multiplication, inverse, and remembering all these formulas and everything we have done manually. Now what we have done previously in our previous session, we did the same thing here, right? We did create an equation. Where is our equation? Yeah. So we just created an equation, said Y with nitro, and create a model and said OLS equation, whatever equation we created, and printed our model, and we got the same coefficients here, right? Now we are trying to redo the same thing. Now, if you see time by nitro, if you do the OLS and get the parameters of the model, intercept and nitro, you're going to get the same thing, right? So the whole exercise of today's, which went a little confusing because all of it's what not clearly explained in the actual session also, because we're not trying to go deep in each of the section, but I hope now you understood and are able to appreciate what is happening behind the scenes, right? So whatever OLS gave, it did all of this math and all of this understanding and gave us this, right? So that is, it is also for us to understand that matrix multiplication is something that happens within most of the functions, the regression functions, or like how Ritesh specified the graded descent, all of these things, the matrix multiplication happens, right? So now if you understood what we have done here, if it's everything is clear, type C in the chat box. Okay, right. So now Jay sir also goes ahead and explains why Python or NumPy, this whole of it, why are these people not doing regular multiplication, why we are doing matrix multiplication, right? So what happens here is there is something called CPU and GPU, right? So I'm just going to show you this diagram that Jay sir shows. Now, what happens is, if at all you're working with normal variables, right? So normal variables, your memory in your system is saved like this. Basically, to do complex calculations, you would require more of this arithmetic logic units, the ALUs, right? So now, if you see any older system or a regular system, the normal RAM with all of that things, the calculation scope for any variables or any mathematical operation is lesser. So now if you look at GPU, which is graphical processing unit, which is more used in games and high definition movie watching and all. So even in high definition movie watching and gaming and all of those things, more units of ALU are going to be processed, right? So for that reason, whole of this matrix multiplication happens on ALUs, right? So we cannot just use a simple mathematical, like right now we are just doing transpose and matrix multiplication and OLS, but we know that the whole NumPy is capable, or whole pandas is capable of doing even complex data science algorithms, which are not going to be just worked upon on regular RAMs or CPUs, right? So it is always because if you see, whole of the variables that you're creating are going to be saved in your memory, right? So for that reason, we have our RAM and disk, right? So whenever you're creating any variable here, it is going to be taking some space in the memory. And when it is becoming a matrix and it is taking a bigger set, data set than a variable, it is taking ALU kind of a memory space. It's not going to just take simple variable space. So whole of this complex arithmetic and operations happen in the GPU area, and where even complex, if at all you take a Google Assistant or Siri level of things, they use different kinds of machines for such operations, right? So just to help, like all of that uses matrix multiplication only, right? So because you have to work with not one variable, you have to work with multiple variables. Yeah, so will Google Colab take our system memory, or will Google provide RAM? So here everything is being provided by Google only, ma'am. So they are allocating small space on their, the larger RAMs or disks, and that is happening. And even Collab has a paid plan. Like for example, there is a limitation till what kind of models you can run. If at all you're trying to, because Google is providing for free, and if somebody says like I'm going to build a complex clone of Siri or Google Assistant, it's not going to happen, because for that you have to go and purchase more space onto it, right? So now there is Collab pricing also. Right, so now you can see there are more plans for running complex algorithms, right? So you can see that faster GPUs, more memory, faster GPUs, and you can see that. So it's not just going to take CPU memory; it's also going to take the GPU memory. The free plan gives you access to everything free, right? You are good for learning and all, but if at all you want to do complex these things, either you have to have your own machine with a good RAM or GPU, or you have to purchase Google Collab's thing. Yeah, so even if the RAM crashes, if you are using Google Collab, it won't affect. Yeah, so that is the reason people who are doing complex machine learning and all, like heavy, high intensive machine learning, the companies themselves provide the systems, right? So for that. Okay, so I hope this all explains everything. Now, what we are going to just do is we're not going to deeply do everything. We are just going to do the same multiple regression example. Now, we have the same data set. Now, here the equation is going to be, because we'll have three variables, the equation is going to be 3. X will have once and the nitro and once again. Why? Because we also have another equation like B0 plus B1x plus B2, right? So I have not requested to go delve into it. Now, what we have done here is we use the same definition function, right? So get will not work here. I'm just going to say generate underscore B, right? Because we have renamed that function. Now, multiple linear, so the multiple linear regression, MLR, or you can just say MLR regression coefficient. Right. So now what is going to happen? Now because we have X and Y, we already have. Y was what? Time only, right? So now we are just going to print our multiple regression coefficient. Now, because, okay, so I'm just going to run this again. Sorry. Okay, now X is something, this is there. Yeah, so the problem with having same names always is the problem. Now we have, with the help of our definition, we got our regression coefficients also. Now, if you see yesterday's session also, the Wednesday session, now you've got your 3 values. So this is what behind the scenes was done by our OLS model, right? So more of it has been explained in depth, the repeat of what we have done similarly here, right? So I hope we are able to appreciate what has happened here. And if there's any query till here, let us know. What we're going to do is we are going to understand more of cosine similarity in our next session, and then we are going to move on to our 3.5. Okay. So the plan was to cover the cosine similarity also today, but because we had to go deeper and understand each step, it took a little time for us, right? So hope everything is clear, and we are concluding our session today, and we are going to resume it tomorrow from here, right? So apart from this, if everything is clear, type C in the chat box. Yeah, thank you so much, Venkatrao sir. Thank you, Vinita. Okay, thank you, Ramesh sir. Thank you, Ritesh. If at all you want to understand cosine similarity by yourself, and if you have the time now, you can just go to the linear algebra lecture of Jain sir, and Jain sir has explained maybe towards the end more about the cosine similarity also. Yeah. Okay. So Ritesh asks, yeah. So I think Rajesh's lecture will directly be there on the upcoming Thursday, Ritesh. Thank you, Ravindra sir. So Deepthi, if at all you are coming to understand more of OLS, you can just go refer from the module 3, which is from here, right? The linear algebra model, right? So you can start understanding more of OLS from here itself. If at all you are starting from beginning, I request you to come from the beginning also. Though linear algebra does not have more of dependency on statistics, but I would still suggest if you are going by your own pace also, it's fine, right? Thank you so much, Deepthi. So Anita ma'am, I think we'll discuss about the Slytherin example tomorrow because taking the time factor into constraint. Okay. Thank you so much, everyone. Thanks for all of your time. Okay. Thank you so much, Anita.